Another draft physics video presentation. Okay, continuing in the Feynman series, we'll finish up. This part has the most bold statement in it, in the sense that Feynman is overtly saying the universe is woo. Okay, God does play dice with the universe. You don't like it tough. He doesn't say that. He says that 15 years later. But that's the theme here, is that there are no conditions that the universe is in, and you can't duplicate the conditions, and you won't get the same results. So same conditions don't produce same results because there's stuff in the universe that's doing some kind of magical thing, and that we are ridiculous to think otherwise. Because the evidence is so overwhelming, because they have a misdescribed experiment, and they have magical experiments they never did that they assume the results of, and because they have magical experiments they never did that they assume the results of, and they can misdescribe another experiment where they didn't even do it themselves, obviously. They're just taking somebody's word for what the patterns are, or they're taking the 200-year-old version of the experiment and showing us that pattern, and they scribble it on their little boards very imprecisely and say that's the reality. And we know it because we have a scribbly, crappy experiment that we don't really analyze with any kind of, scientific scrutiny. And we have experiments we never did that we assume the results of. And you're an idiot if you don't believe us. Because we've proven it. So that's the, that's the background for this insane conversation. I could find other physicists that are trying to duplicate a modern version of Feynman, and they'll do exactly the same thing. Leonard Susskind, paid college professor, he'll do the same shit. He'll make the same arguments like they're really good arguments. 50 years later, he'll say the same crap as if it's the truth. When no, it's not really. I mean, it would be a silly definition of truth to say they're telling you the truth. It would be silly.
In these two different ways at the same time. And that's all there is to say. I give a mathematical description to figure out the probability of arrival.
Right, yeah, mathematical description. A plus B equals A plus B squared or something. There, I've done it. I've given you this huge, powerful mathematical statement. I squared the probabilities. There, We're all done now. I did Pythagorean math. Therefore, I've proven that the universe is woo. No.
Of electrons under any circumstances and so on, and that would...
Electron and so on, and what for, and photons are the same, and it doesn't matter what I shove through this slit, same thing happens, blah, 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 blah. No evidence of any of this crap.
This will be the end of the lecture, except that there are a number of subtleties involved in the fact that nature works this way. There's a number of peculiar things.
So again, the way nature's working, okay, oops, we have a little camera failure. Obviously it wasn't the camera's fault entirely. I helped the camera fail. So obviously it wasn't woo, it wasn't a quantum failure. Okay, the quantum woo magical thing didn't happen, and it actually was a physical consequence. My foot had actually hit the cord. Yeah. All right. So let's understand that. This is like the analysis of their analysis of a photon. I've already pointed out how it's superficial, right? They'll draw you some silly thing and say, look, it's got two fields that are being perturbated. One's going this way and one's going this way, and these fields are blah blah blah, and somehow they're affecting an electron, single electron. We're going to get into that, which is, nonsense. But we know, okay, again, we know that this event of creating a pattern, we know now, okay, Young didn't figure it out, but we know that there's this key event that happens. And so they have had math in the past, and they use this kind of simple and trivial math, this wave equation math, And they have two different versions of it, but neither version accounts for this. Okay, so the two simple versions of the math don't work, because they won't put this dead space won't end up where it's supposed to be. And this is all math based on this idea of slits. Okay, and they're just going to do this little wave thing, and they could draw their little waves and their waves intersecting, and they can figure out where the little spots will be. You know, but they really didn't analyze what those waves really are. It's just 2 point sources. That's what a wave actually is. A wave with a spherical shape to it. It really is just a bunch of point sources, you know, a point source radiating, okay, equidistant radiation. So they didn't even do enough analysis to figure out that simple thing, that a round wave, a circular wave, is really just like having a little light source or something, some point source, and it has rays. And the rays are really deciding, you know, the event, right? A ray from here and a ray from here, and that'll get you in phase. Then, you know, the notches line up, so to speak, the phase notches line up. Then you'll get light there and dark and light and dark. Okay, well, this math doesn't work. This is no good. It fails to get this accurate. And so the math they really need to use, okay, is a more complex math. And that more complex math is essentially establishing that, no, it's not 2 wave centers, it's actually 4 centers, 4 point sources. And the 4 point sources work if you understand the 4 point sources are really 2 distant sources. 2 uneven distances. The uneven distance between this line and this line, that is this line and this line, very different distances, and then the inequality of these 2 lines, this point and this point. And really those are the ones deciding the size of the pattern. Okay, so the small pattern's being created by these 2 outside sources. That's these little bars. And the big bars, that is the big pattern, this pattern, is being created by these 2 sources. So that's all. We're done. That's the real analysis. No woo needed. No, I have to imagine photons being, you know, wooed into a position. All we know is that these are the point sources. These are the places where action's happening. The action, okay, the photons that don't go straight through, are these ones that are right next to the point sources. Obviously, the ones next to the surface are the photons making all of this diffraction pattern. None of the photons that weren't screwed up by going through, they went through the center of the slit, didn't get hit by anything. They're ending up going right to the middle, and they're just doing their normal thing. It's only these ones close to the slit that are being forced to show up at one of these locations. And again, all the locations can be defined on that curve. So the number of wavelengths you have in this total distance, okay, that's the notches you'll have that for the little bits, and the total number of notches you have inside this impediment, that will define these big notches, you know, the big pattern. And where the 2 add, you get a big bright spot, and where the 2 don't add, because one of them's out of phase, you know, this one isn't in phase with this little one, then you'll get the little X, you'll get the place where there's nothing. That's it. No will required to explain the phenomenon, and the math is obviously simple. The math is just, you figure out how many wavelengths fit in this difference in the distance, right? The difference in this distance, and then the difference in the line here from the line here. You find out how many wavelengths are in that difference in the distance, and you just superimpose it over the circumference, and you have your answer. I mean, you have to multiply it by 2 because it only shows you one side at a time. The number is only going to be for one side. So you just multiply it by 2, put it over the circumference. You'll know exactly how many notches are on the circumference, and you'll know exactly how far apart they are. That's all. Done. No randomness in the universe. The universe doesn't have to make any randomness.
And I would like to discuss those peculiarities because they may not be self-evident at this point.
Right, so one of the biggest peculiarities, which they knew at this time when he made this video, is that the real two-slit pattern stop it, please. There we go. The real two-slit pattern has the two patterns built into it. Stop it! You're going to piss me off. You're not going to like me when I'm angry. Anyway.
So to discuss the subtleties, we begin by discussing...
So, again, there's no subtleties. They don't discuss the subtlety of what a photon is. They don't discuss the subtlety of how electrons get propelled. They don't discuss the subtlety, the details, the nuances of any of this physics. They don't pay any attention to it. Like when, they'll talk about light and spaceships going twice the speed of, half the speed of light. And they won't even account for the fact that the photon itself is being ejected into space in different places, and its polarization is getting insanely stretched, and you would never see it as a photon. It could never hit the mirror. They don't go through any of this physics. The physics is these circumstances of figuring out, these mechanical circumstances. Like I could have a mirror, right, that's reflecting light at me, and I could be saying, that's a certain amount of pressure it's creating. And say if the mirror was moving, right, it was moving 6 inches closer and then 6 inches further away. I can understand that the further away I put that mirror, the more that 6 inches gets to be nothing, because it's the length of distance from me that 6 inches has to be added, subtracted from. And so the further away I go, the more impossible it will be to see that 6-inch difference. The mirror never gets smaller, but obviously the amount of light I see will get smaller, because some of the light I saw when it was close was photons moving at different angles. All of those details are never part of their analysis. They never do mechanics. They stop. They stop at tire, wheels, car frame, steering wheel. They never go into plastics and steel and rubber, and they never go into what is the thing really made out of. And it's just so ironic that they call themselves physicists. It's one of the greatest imbecilities of our time. And they call themselves particle physicists, which is even more ludicrous, when they don't believe in particles.
A proposition which we would have thought to use since these things are laws. Since what comes is always one complete which I'll call...
Yeah. Okay, so this is the joke, right? Because, again, any kind of superficial even, not too detailed analysis, you'll say to yourself, well, what is a photon, right? What exactly is a photon? Is a photon, this much, this much, this much, this much? So again, that's like the first thing you should ask yourself. What do you mean photon? What is a photon? And we know the photon has these two features. It has a length in space, and it has this polarization thing, which is it has a width in space in one of the dimensions. In one dimension, it has a width. So a photon is something like this, right? It's some sort of little shape, okay, moving through space. It's a shape. It's a cubic kind of thing. Okay, I drew that poorly. Well, I guess I can fix it by doing that, maybe. Anyway, so it's a thing, okay? It's a, it doesn't have this part, this thickness. I probably shouldn't have given it any of that. It's like a piece of paper going through space. It has length this way and it has length this way, but it has very little width this way. But they don't even bother with saying something is like a piece of paper going through space. They don't give it any form or shape. And they just tell you, this is a yeah, okay? A yeah shows up. Well, why does a yeah show up? Well, that's because your detector can only detect yas. So of course it comes in clumps because all you have is a clump detector. You don't have a detector that sees this, this, or this. You have a detector that has to see this. Okay, so it sees a clump. So of course you say it comes in clumps because all you can see is clumps. I mean, man. I mean, this is such terrible foundation for their theory. That's all. I mean, for you people out there devoted to their, these wonderful gods of physics. I mean, you can't admit that this is really shabby crap that they've built this whole thing out of. The evidence isn't startlingly clear. I mean, this is not a gigantic brontosaurus or tyrannosaurus skeleton you dug out of the ground. This is not impressive evidence for the universe has a god in it and he's playing dice with us.
An electron. One complete lump, one complete electron. It's obvious that...
So obviously for electrons it's a little less complicated in terms of visualizing. But the other problem with electrons is again, this is their theory. So I'm just saying, you have to hear what they're saying, right? Now we know the polarization of a photon is thousands of atoms worth of polarization. Thousands, okay? So it's polarization. It's the piece of paper, of the photon, okay? It has this length thing and it has this height thing, all right? And so we know it has this height is huge. By standards of sizes of subnuclear particles, subatomic particles, it's gigantic, okay? Many, many atoms across. And so they're saying this thing that's many atoms across, and we know an electron is 1/millionth, probably 1/billionth, the size of an atom. The electron is a tiny little frickin' thing. And their theory, he's going to sit there and talk to you as if they could really do this. That they could take this giant thing, whether you think it's a wave or whatever you think it is more than 1 million, maybe 1 billion, maybe 1 trillion times bigger than this. And that this somehow bounces off of the electron, the single electron. Now the fact is, the evidence is that they have a bunch of atoms in a substance, and when they shoot a photon at that stuff, they know that photons will reflect off of the electrons. But obviously it's going to reflect off a whole bunch of electrons. Pieces of the wave will hit the different electrons and cause the different electrons to do something similar. And when they do something similar, that'll create electricity. Okay? But it won't be one single electron that creates the photon. And they already know this. And they know also that this energy is huge from an electron's point of view. A photon is a gigantic thing, an elephant hitting, sitting on a ladybug. The electrons are going to be catastrophically influenced in where they're going to be. They're going to move a lot. They have to move a lot to create electricity, obviously. They have to move a lot. So obviously you can't see electrons where they are. There's no hope. It's, a silly conversation. And yet they have it as if, well, because we can't, they're making both arguments. Because we can't see an electron, therefore it's woo. And they're making the argument that even if we do bounce something off of it, we can't see. Well, I don't even know how to say that, but they're just sitting there saying we've debunked any possibility of having any kind of physical mechanism because this is 1 trillion times bigger than this. No, that doesn't prove anything about woo. The fact that we can't see an electron does not mean that we can't see it because God says so. And he's going to bring up Heisenberg God. This is, like I said, it's a religion.
It's reasonable.
Yeah, it's reasonable. That was funny. Yeah, I thought it was funny too. Yeah, it's like funny, sad, and tragically funny. So I guess we can get rid of this and then just play this. Yeah.
That either an electron arrives, or goes, let's say, that either an electron goes through hole number 1, or it goes through hole number 2. Let's see.
So again, this is just because they never really thought about this photon being a composite. Never thought, so this is all goes to hidden variable theory. So they never thought that there could be some variable that, no, what really happens is some photons go straight through and don't get disturbed. Some photons have pieces of them wiped out by the surfaces. You know, they just absorbs part of their energy, and so only part of the energy of the photon gets through. And then some are just deflected because they hit electrons, and you know, pieces of the photon go to different locations. One photon will be broken into 6 different pieces that go to 6 different places. And the fact is that you can put them back in the right order. They're just bullets. The quanta is just a bullet. Me and Feynman might agree with that. You know, the quanta is just the quanta. Quanta, it doesn't matter. So it's all just bullets, and all you're doing is, can I put the bullets back in the right order or not? And of course you can, because the order just is a place in space, and so obviously you can put them back in their place in space.
Like it goes through hole number 2. That seems very obvious that it can't do anything else if it's alone. And I'm going to discuss this proposition, so I have to give it a name. I'll call it Proposition A. Now we've already discussed.
So again, Proposition A is just an assumption. So you all agree that somehow this is a brilliant assumption that we're going to assume the photon is completely undisturbed by the physical thing you're forcing it through, even though you know its polarization is quite huge, and that there's no such thing as breaking a photon. There's no such thing as knocking it into pieces. So they've just said that a photon is some hard object like an electron. There's no evidence that you could ever break it into anything. It's indestructible. Well, clearly the little bits, I would argue, are indestructible, but the idea of the photon is completely destructible. You can rearrange those little bits into anything.
Just a little bit what happens with Proposition A. If it were true that an electron either goes through hole number 1 or it goes through hole number 2, then the total number which arrive here would have to be analyzable as a sum of 2 contributions. The total number which arrive here will be the number that come here via hole 1 plus the number that come via hole 2.
So we know that the real mathematics that works is the mathematical that has 4 point sources. So it's not about hole 1 and hole 2. It's about the surface of hole 1 and the surface of hole 2 and then the surface of hole 2 and the whole. It's about the 4 surfaces. And the 4 surfaces are doing something, which is they're changing the photons. They're breaking them, and then you remake them. There's no destructive interference. There's just constructive reconstruction. That theory works just fine. He never thought of it, and he never considered it, because he never really thought about how the experiment works. He never drew it on a frickin' board and said, how big is a photon? How do I bounce it off of an electron? Yeah, that's kind of silly. The photon is 1 trillion times bigger than the electron. How the hell do I bounce that off of an electron? That doesn't sound very practical. Why am I teaching that? That sounds kind of wacky and silly.
And since this curve cannot easily be analyzed as a sum of 2 pieces in such a nice manner, and since the experiments which determine how many would have arrived would have arrived, if only hole number 1 were open, don't give the result that this number is the sum of...
So he says the experiments that do this. There's no experiment that does this. Just understand how difficult this experiment is for electrons, especially. It's difficult for photons, even though photons are big and huge, 1 trillion times bigger than electrons. It's still difficult. And so this whole cover one of the surfaces idea, that, they have the 2 slits and we're going to cover one of them and have results. There's no good experiments doing this. And especially back in Feynman's day, they had no experiment where they could tell, which electron was going through which slit, that they had any way of detecting an electron, they had any hope of doing any such thing. And that they had any hope of counting it. The only way you can know which slit it goes through is to aim it. Okay, and we can't aim electrons very well, not fine enough to get them through a tiny slit, because they're tiny. It has to go through a very tiny slit, right? I mean, obviously, the whole point of this thing is when the slit gets smaller, it means the surfaces get closer, which means you're more likely to go by a surface. Obviously, if the electron's a trillion times smaller than a photon, you need a really tiny slit, right? I mean, insanely small for the surfaces to be at all interesting. So doesn't this experiment become impossible just as a practical matter? I mean, creating a slit proportionally as small as the polarization of light, the wavelength of light, right? The wavelength of light is the proportional to the polarization. So the polarization and the wavelength are the same. To do the experiment at the wavelength of the size of an electron, okay, the slit has to be a trillion times smaller than the light slit. A trillion times. A billion, let's just say, for the sake of argument. A billion times smaller. We can't make any such slit. So the experiment, you can't do a two-slit experiment on an electron. You just can't do it. Not possible.
These two, it is obvious that we should conclude that this proposition is false. It is not true that the electron either comes through hole number 1 or hole number 2. Maybe it divides itself in half temporarily and so on. So proposition A is false. That's logic. Unfortunately...
Yeah, it's logic and it went incomplete. So you've eliminated a whole bunch of possibilities with your axioms. You've ignored the actual size of objects. You've pretended there isn't real physics here. That is, surfaces aren't made out of atomic particles, that there aren't electrons covering the surface of things. You've made all these assumptions that are so counter to obvious truth. I mean, the fact is the photon has to have a length. And it has to be part of your definition. And you know the length of the photon has to be longer than just one node. So, you haven't even, figured out these simple observational things because you never drew it. You never modeled it. You never tried to explain it by being fair to it.
Or otherwise, we can test logic by experiment. And so we just have to do to find out whether it's true or not that the electrons come through hole 1 and hole 2, or maybe they go around through both holes and they split up and so on. All we have to do is watch them. We watch them, we need light. So we put back here behind the holes a source of light. It's very intense light.
All right, so this never happened, right? So he describes it as if they did this experiment. They never did this. This is just thought experiments. Because when he starts to talk about, well, we could use anything. We could use light. We could use kaons. We could use neutrinos. We could use anything. And we'd get the same result. They never did any of those experiments. So he's just assuming this is what the effect would be. It has nothing to do with a real experiment that demonstrated that this is a truth. And I'll explain further why we know it can't be that they did the experiment. We know they didn't do it. Because it can't work the way he said it works.
Light is scattered by electrons. It is bounced off electrons.
Okay, so yes, and that phenomenon always happens when millions of photons, or billions or trillions or zillions of them go into a system. Then we get a certain number of them back. Okay, but we're not getting the photons we sent. We're getting pieces of them being recombined in the same phase, in the same pattern, and so we're getting a new photon. Okay, made out of elements of the photons we sent in. And that's the truth of it. We're not getting back what we sent. We're getting a representation of it made out of the pieces that were broken off of what we sent.
In other words, you can see electrons if they go by if the light's strong enough. So we stand back here and we look to see whether we see, when the electron is counted here, a flash or have seen the moment.
All right, so let's just understand, okay? We know that can't be the truth. All right, that photons, we should expect photons to bounce off of electrons. We know that's not what happens. I mean, there's scatter, there's all kinds of things that happen, but we know it just doesn't reflect light back. Like, here's an electron, it reflected the light back. That doesn't happen That's nonsense. There's no evidence of it, and you can understand why it's nonsense because the photon's a trillion times bigger than the electron.
Before the electrons stop here, a flash behind hole 1 or a flash behind hole 2, or maybe a sort of a half flash in each place at the same time. Because we're going to find out now how it goes by looking. Well, you turn on the light and look, and lo, you discover that you see flashes behind either one hole or the other hole every time.
So he says it, right? And so we did the experiment and we looked, and what do you find, right? Isn't it being described as an experiment that was done? It clearly wasn't done in Feynman's time. It clearly wasn't done when he's making this video. So this is just made up. This is a made-up experiment, never performed, and he's using for evidence of why it can't be. And you're telling me that this is good science. No, it's rubbish. It's crap. It's religious theater. It's a very nice sermon.
You get a count here. Every time there's a count here, you see a flash behind number 1 or behind number 2. What you see is that the electron comes 100% complete through hole 1 or through hole 2. When you look, kind of a paradox. Well, let's squeeze nature into some kind of a difficulty here. I show you what we're going to...
Yeah, with a pretend experiment. Let's really analyze it with our magnifying glass made out of imagination. I can see Sissy and Susie. I see you too, Jimmy, through my little magical mirror. Let's just make up the reality.
Do, see? We're going to keep the light on. We're going to watch.
Few people will get that reference, but yeah, I grew up with TV that was really cool. You know, there was really cool TV shows on when I was a kid.
We're going to count how many electrons come through. And we're going to make 2 columns.
Alright, so this is so silly and it's sort of a waste of everyone's time, but I'll play it because it's part of what his argument was. And to me, a very silly argument.
I'll watch the holes very carefully while you please count how many are arriving in the detector. All right, you say, 1 arrived. I said, I saw that when it went through hole number 1. So we put here 2 columns, which is column 1 for number 1 hole and number 2 hole. And every time you get one, you tell me about what I have seen it, of course. And I say either number 1 or 2. The first one was 1. What's the next one? Number 2. All right. Number 2. Number 2. Number 1. So as we watch the electrons, as I watch the...
So he's selling this as if they actually did the experiment. Never done.
Electrons, for every one that you count, I can separate them experimentally into 2 columns. Them what have arrived via hole 1, and those, I know the English is right, I'm just trying to, that arrived via hole 2. So then...
Don't get me wrong, I like Feynman. He's funny and interesting and quirky and strange. And, you know, those are all admirable qualities in a human being. But this is shit as science.
The total number that arrived. Well, first, what does this column look like when you add it all together for different positions here, which is just the number that is supposed to come through 1. I watch behind 1, and what do I see? I see this curve.
Okay, so he says, I see this curve. Right, so I see the curve as if the electrons were never disturbed and they just went through a single slit, let's say. But we already know that they're going to be fucked up by a single slit. So we already know that curve isn't reality anyway, right? That the single slit also causes a pattern. And it wouldn't just create a blob. Now, the bullets might be more blobby, okay? But we know photons won't be blobby. And we don't really have any expectation that electrons would be blobby. So that was part of this made-up physics also. You know, there's no experiment that shows you this blob. Okay, there's no blob experiment that shows you the blob. So let's just, you know, again, people all fall for this crap, so I really have to explain it like you're fucking idiots, right? Because what else is there? I mean, I can't help that you're so stupid. So the argument is that somehow we should expect that when light goes through here, it just creates a blob. And they kind of are saying that's the truth, right? When we know a single slit will create pattern, okay? Little bars, just, you know, like the double slit, except the bars will be in different positions, okay? And the center bar will be twice as big. We know that's the truth. But anyway, let's just say the blob theory is correct, even though I'm telling you overtly it's not correct. let's say it was a blob. Now he's saying I put a light emitter here, okay, and a detector over here, or I put a detector here to get reflections off of these electrons, right? So I'm not seeing their shadow, I'm seeing a reflected photon. All right, so I'm gonna detect the reflection with my little detector device. Never happened. His argument is that, okay, when I see it, that is, the light hits it and it bounces into my detector, it makes a blob. Well, you know, right? I don't have to tell you that when you hit an electron with a photon, the electron is going to go this way. It might go this way. It might go this way. But we know it's going to go in that direction, right? It's not going to go in this direction at all, ever, right? I hit it with the photon, it's never going this way. So we know that this part of the pattern is doomed, right? This part of the curve is totally screwed. And we know that the curve is going to end up being this, okay? That's what it's going to be. All right, it's going to be this. That's where you're going to see the electrons. It's way the hell over here, and way the hell over here, and way the hell over here, because they're all going to be going on this arc. This part of the arc is the only part of the arc you're going to see any electrons in. So we know that this is where the peak of the pattern, you know, I mean, it's going that away. So we know, theoretically, it's nonsense to say I hit the photon, I hit the electron with a photon, caught the reflection light, and the electron did exactly what it would do if I didn't hit it. We know that can't be the right answer, right? So what is there to argue here? This is garbage. This is nonsense. This is just lies you tell this stupid congregation about how proven your God is. You know. They have fossils with, you know, credit cards in them. You know. Dinosaurs are fake.
Just like we thought when we closed hole 2. Works the same way whether we're looking or not. If we close hole 2, we get the same distribution in those that arrive as if we had watched.
All right, so again, he's talking as if he has evidence for this statement. He has zero evidence, zero experimental evidence, zero.
And likewise, the number in this column that is supposed to arrive via hole number 2 is also the simple curve. Now look.
Now look, you know, right? See, it'd be really cool if he said right now, look, you know that there's no way I hit those electrons and they didn't move somewhere else. Oh, yeah, you know I'm full of crap.
The total number which arrives has to be the total number. I'm just counting little marks. It has to be the sum of this number plus that number. The total number which arrives absolutely has to be the sum of these two. It has.
Okay, if you believe what his story is, which isn't accurate, which is that somehow the electrons aren't bent, you know, by the surfaces.
It has to be distributed this way. When I said it was distributed this way, it's distributed this way. It really is, but it has to be. It is. It's distributed this way. If then we...
So again, the real giveaway here is yes, you get this simple pattern. Okay, let's say a simpler pattern, just to make it simple. And when both slits are open, though, there's really, you're introducing two new sources. And that's really what it's about. There's two sources, and there's two sources. 2 plus 2 is 4. 2 plus 2 isn't 3, or 2 plus 2 isn't 2. So that's why the two patterns, when they're combined, are different, because you're going from 2 to 4.
Start with a prime, the results. When a light is lit, prime means with a light lit. Then we find N1 prime is practically the same as N1 without the light, and N2 prime is almost the same as N2. But the number that we see when the light is on is equal to the number that we see through 1 plus the number that we see through 2. This is the result that we get when the light is on.
So again, they never did the experiment. They wouldn't arrive in the same locations. He's just made this part up that there won't be any pattern. Now, I'll agree there won't be any pattern because the pattern is made out of more than one particle. And that's why the electron experiments is so difficult. And that's why every image you see that where they say they're doing the electron experiment, there's good reason to be suspicious.
In other words,
Suspicious that some other energy is causing the pattern, not just the electrons. Because detecting electrons is, again, as I stated, a little bit nuanced. Because lots of energy will create something that can look like an electron.
you get a different answer whether I turn on the light or not. If I have the light turned on, this is the distribution which you measure over here. If I turn off the light, this is the distribution which you measure.
I mean, let's understand. I mean, the photographic film can pick up electrons.
Turn on the light, this is the answer. Turn off the light, that's the answer. See, they just squeezed out. Now, we could say then that the light affects the result. If the light is on, you get a different answer than if the light is off. If you want to, you can say the light affects, it does affect. In fact, we found this by this experiment, we get a difference with the light on and off. Light affects it.
So he's, again, saying it as if they did the experiment, when, as I already just pointed out, we know we can't detect a single electron with a photon. There's no experiment doing that.
Behavior of electrons. If you want to talk about the motion of the electrons through here, which is a little inaccurate, you can say then that the light affects the motion, so that those which might have arrived at the maximum are somehow been deviated or kicked by the light and arrive at the minimum instead, so smoothing the curve to produce this thing.
Right, never produce that thing, right? We already, like I said, we already know we're giving them the electrons momentum by detecting them, and the momentum will be in a different direction than that direction, and we can't create that pattern. So again, you know this wasn't a real experiment he's describing. It's a thought experiment. And then he's going to use the thought experiment to say, well, because we proved it with electrons, we can surmise the same is true for kaons and neutrinos. So he's using the fake experiment as evidence for why, we should assume that the other things behave just like the other fake experiment. I mean, it's that bad.
You see, electrons are very delicate. Although when you're looking at a baseball and you shine light on it, it doesn't make any difference. The baseball goes the same way. Electrons are very flimsy, very delicate.
No, they're very small. Period. Even if they were the size of an atom, they would still be 2,000 times smaller than the polarization of light. So even if they were as big as an atom, and we know that they're preposterously smaller than an atom.
When you shine a light on it, it's a little tough on the electrons. It knocks them about a bit, and instead of doing that, they do this, because you turn the light on so strong.
So again, we know logically it wouldn't do the same pattern as if you hit them and don't hit them, we'd get the same pattern. We know that's not true. If we assume this stupid clump, this little bump, this hill, this mountain he draws, we know the mountain would be very distorted.
You hit him with a hammer. It's not just a delicate thing like when you're looking into the face at a baseball with light. They are hit him with a hammer. What you turn up the light too strong. Turn it weaker and weaker and weaker until it's very dim. Then use very careful detectors that can see very dim light. And look with the dim light. Now, as the light gets dimmer and dimmer, you can't expect with very, very, very weak light to affect the electron so completely as to change the pattern 100% from this pattern to this pattern. As the light gets weaker and weaker and weaker, somehow it should get more and more like no light at all. And how then does this turn into that?
Well, again, so this is theoretical nonsense, right? Also, just because of the obvious thing that we already know that photons are clumps. And you can hit them with 2 clumps or 3 clumps, but you know you're not hitting an electron in one single electron with 2 or 3 of these things.
It turns out that light is not like a wave of water, but light also comes in particle-like character called photon.
So this is the irony of it, right? That even though he's not a wave nut, okay, doesn't like wave theory much, he's still resistant to a mechanical system. And so his woo is, yes, go all the way back to the Bohr-Einstein argument, and Bohr is right. Quit telling God what to do. God does play dice with the universe.
And as you turn down the intensity of the light, you're not turning down this effect, you're turning down the number of photon particle-like things that are coming out of the source.
Particle-like things. I mean, that would be, see, he's getting closer, right? Particle-like things. So then maybe you could think of it as being a collection of particles at a frequency, and that would define a photon. And obviously it can't have a frequency unless there's at least 2 of them, right? But we know we don't see those. Those might be gravity. Yeah. Newsflash. The little tiny rays might be gravity.
So as I turn down the light, I'm getting fewer and fewer photons. The least I can scatter from an electron is 1 photon, and if I have too few photons, well, sometimes the electron will get through, and it just happened, there wasn't enough light, there was no photon coming by, I didn't see it. So a very weak light doesn't mean a small disturbance, it just means a few photons. And what happens is that I have to invent a third column. You see, you get a click over...
So I wish you'd just say, I have to invent another fake experiment that we didn't do. Because that's what he's going to do here. He's going to take his fake experiment and double down on it.
Over here, I saw that one, that was in number 1 hole. This was behind hole number 2. Then another column, sorry, I didn't see that. There wasn't enough light to give a photon at that time, so there must be a third column under didn't see. And when the light is very strong, there are very few in there. When the light is very weak, most of them end in there. So that there are 3 columns, this one, and sometimes in here. Now you can guess what happens.
You can guess what happens, right? Well, we don't do the experiment. It makes it really easy to guess what happens when you don't do the experiment, because then you can just make it up. And he just makes it up.
The ones I do see are distributed this way. The ones I didn't see are distributed that way.
Right. So he's telling us as if this is what happened, when it never happened.
And as I turn the light weaker and weaker, well, I see less and less of them, with greater and greater fraction are not seen. And the actual curve, in any case, is a sum of a mixture of this and this, and as the light gets weaker, so that fewer and fewer are seen, it gets more and more like that in a continuous fashion. So,
so there's no experiment. It just doesn't exist.
In this case, if the electrons are not seen and nothing bounced off the light under those circumstances, you get this complicated pattern. For those electrons which were not seen, the ones in the column didn't see are exactly distributed.
Let's understand, you can't make a slit small enough to crowd an electron, right? We're talking about crowding something, right? The whole point of the slit is that it has to kind of constrict the photons. It has to force them to go by the surface. You can't make a surface small enough, a hole small enough to confine an electron, to make it inevitable that the electron will travel close to the surface. We can't make any such slit.
In this complicated way, and the other 2 columns are in these 2 words here.
Again, use their own rhetoric. They're saying that the electron, the atom, contains 99.999999% of its volume is empty space. How can you be constricting, even if I made a slit as thin as an atom? There's a million places the electron can go where there's no electrons. There's no surface. It's likely to pass through without noticing.
Now, you say, I got another way to measure which hole it goes through. And I'm sorry I haven't got enough time to discuss a large number of different inventions that you might have to find out which hole the electron went through and what happens in each case.
So again, he's citing the experiments that never done, saying we have a whole bunch of these experiments that, prove all this stuff, when they don't have any of these experiments. They don't. It's just crap.
Always turns out, however.
It always turns out. So he's just saying it again, as if they did this experiment he's citing here. They never did it.
That it's impossible to arrange the light in any way so that you can tell through which hole the thing is going without disturbing the pattern of arrival of the electrons from this form to this form, without destroying the interference. And not only light, but anything else. You use neutrinos, you use anything. There's a principle that's impossible to do it. You can't...
See, the principle is, it's impossible to do it, so therefore we don't have to do the experiment because we have the principle. Because we proved the principle. It was proven when Heisenberg said it. It made it a truth, and therefore we don't have to prove it because Heisenberg said it and it's a truth. So therefore it's true. That's all this is. The God Heisenberg says so. It's now written on stone. Thou shalt not bite into a Tootsie Pop.
You can, if you want, invent a way to tell which hole the electron's going through. Then it turns out it's going through one or the other. But if you try to make that instrument so that at the same time it doesn't disturb the motion of the electron, then what happens is you get back. You can't tell anymore which one it goes through, and you get this. If you can tell, you get this. Heisenberg noticed when he discovered the laws of quantum...
He discovered them. Oh, I thought he just made them up. Fuck me.
mechanics that the new laws of nature that he discovered could only be consistent if there was some basic limitation to our experimental abilities that had not been previously recognized.
That didn't even happen either. That's not what he did. He just made this, oh shit, this all seems really hard to figure out how anything could do all this stuff, and we can't do it, and we can't see it. Well, why not, let's just pretend we can't see it because God says so. And of course, Schrodinger and Einstein didn't care for that very much, and so they argued, you people are religious kooks. And they made up, thought experiments about dead cats and seeing the moon disappearing and all kinds of other crap, and nobody got it. Nobody got that, wow, yeah, it really is a silly theory. That the cat's dead and alive. Yeah, that's really silly. Fuck that shit.
In other words, you can't experimentally be as delicate as you wish. And he proposed his uncertainty principle, which stated in terms of our experiment is the following. He's stated it another way, but they're exactly equivalent. You can get from one to the other, but unfortunately I haven't time to explain that.
Yeah, whatever. yeah, I know, unfortunately.
But in our experiment, his uncertainty principle would be stated in this manner. It is impossible to design any apparatus whatsoever to determine which hole the electron passes, and when one succeeds in determining which hole the electron passes, through which hole the electron, which can determine through which hole the electron passes, that will not at the same time disturb the electron enough to destroy the interference pattern.
Obviously, that's not what Heisenberg said. So what Heisenberg said is that the quality of the actual players, the checkers, aren't on the board. They're magically, in a superposition of multiple places, and they don't know where the hell they are, and that's why we can't measure them, is because they keep changing their position. So, and the more we try to measure them, the more position changes they do, just to be obnoxious.
And no one has found a way around this, and I'm sure you're all itching with inventions.
Right, well, there's no way around the fact that you can't see the smallest thing because you can't make a ruler small enough to see the smallest thing. So, yeah, duh. Right? I can't make a ruler that has more than the size of the thing I'm trying to measure. I can't make that if I don't have a world that, creates the opportunity to do that. So I can't measure the smallest thing because I can't make a ruler small enough to see it, to segment it. Because the smallest thing I can't put subdivisions on the ruler because there's no smaller thing to write the subdivisions with.
As to methods of detecting which hole the electron went through, but if each one of them is analyzed carefully, you'll find out there's something the matter with it, and that if, without disturbing the electron, you think you could do it. But it turns out there's always something the matter, and you can account for the difference in the patterns due to the disturbance of the instruments used to determine through which hole the electron comes.
Yes, well, that would be fine. If that's what Heisenberg was saying, I don't have a disagreement. That's right. There's no smaller thing to look at the small things with. There's no light to bounce off of it. You have to hit a Volkswagen with a Volkswagen, and that's not going to tell you much about the Volkswagen, where it was going.
Now, this, therefore, is a basic characteristic of nature and tells us something about everything. If a new particle is found tomorrow, the kaon, actually it's already been found, something, give it a name, let's say a kaon. And I use kaons to interact with electrons to determine which hole the electron is going to. I already know ahead of time, I hope, enough about the behavior of the kaon to say that it cannot be of such a type that I could tell through which hole the electron would go without at the same time producing a disturbance on the electron that change the pattern from here to here. So that uncertainty principle is used as a general principle to guess ahead.
So again, it's a silly principle, completely breaks the idea of what we understand to be the reality. The reality is, okay, there's these small things, and I can't see this small thing by hitting it with something bigger. It makes sense that you can't do that. And that's it. That's all there is. This isn't, therefore I can invent woo. Because of that physical fact that I can't, there's no photon relative to a photon. There's no tiny little thing that I can hit the photon with to undisturb it but get a signal back. Duh. That doesn't give you license to say the universe is unmechanical at the size level of photons. That somehow photons don't have a place. That they don't have a position. They don't have a momentum, and they don't have a direction. Yes, they do.
Many of the characteristics of unknown objects, they are limited in their character. Well then, let's go back. What about this proposition A? Does it go either to one hole or the other? Why not? Well, physicists have a convention, a way of avoiding the pitfalls which exist, and they make their game, their rules of thinking as follows.
These are their rationalizations. So he's basically saying, yes, well, when physicists run up against a barrier, they just open the Book of Wu and say, what does the Book of Wu give us the option to do? Well, we can't make gremlins because, yeah, they already invented those. That was silly. So we can't do aliens. Now that won't work. Let's do magical poof. Yeah, nobody's done magical poof. Let's do magical poof.
If you have an apparatus which is capable of telling which hole the electron goes through, and you can have such apparatus.
No, you can't. Okay? You can't. You can't realistically, right? I'm just pointed out. You can't. You can't see which hole it went through without sending it to, Valhalla.
Then one can say that it either goes through one hole or the other. And it does when you look at all these is going through one hole or the other. When you look. But when you do not try to determine, or you have no disturbance, no apparatus there to determine through which hole the thing goes, under those circumstances...
Aim the photons. See, you could do this two-slit experiment. You have to just come up with some fancier way to do it to keep the light in phase. So I would speculate that if they figured out how to do this without screwing up the phase of the photons by having them travel a different path, that isn't the same path, right? So the idea would be is you just want to split the photons. That is, you have the photons coming in and they're in phase. The pieces are in phase anyway. The individual photons are obviously in phase. And the idea is you want to be able to create two beams and then do your slit experiment with two separate beams. Every way you come up with to try to split, to take these photons and send them somewhere, you have the irregularity of the fact that now you've changed the distance the photons are going to travel, and so now you've knocked them out of phase. So they won't go into the two slits in phase. They'll go into the two slits, with the phase broken. That is, out of phase. So now your pieces won't be able to put together the same photons in the same location and all that crap. So that's the limitation, is as soon as you interfere to try to create two beams of light to duplicate slits, you're inevitably going to change the phase of the light.
You cannot say that it either goes through one hole or the other. You can always say it, provided you stop thinking immediately and don't make any deduction from it. We prefer not to say it, rather than to stop thinking at the moment. In other words, when we don't look, we can't say through which hole it's going, but if you try to look to see, you find it always goes through one hole or the other. Still, to conclude that it goes either through one hole or the other when you're not looking is to produce an error in prediction.
Right, so we know that if we didn't have slits and we just drew slits on a surface, we know a certain amount of light hits one side and we know a certain amount hits the other side, so this isn't complicated. There's no reason to disbelieve that the photon either goes through one slit or the other.
And that is the logical tightrope on which we have to walk if we would.
But there's every good reason to believe that photons are composite objects, and what's happening to them is they're being broken by the process, and you're just putting pieces together.
To interpret nature. This proposition that I'm talking about is more general. It's not just for two holes. Its general proposition reads something like this, that the probability of any event in an ideal experiment, that's just the means that which everything is specified as well as it can be. The probability of an event is the square of something, which I call A here, is called the probability amplitude. And when an event can occur in several alternative ways, the probability amplitude is A number, is the sum of the A's for each of the various alternatives.
Right, so probability just turned again, this is just Pythagorean kind of theory. We're taking the area and using the area as the hypotenuse is the way the addition works. So it's like adding the two sides and you end up with a hypotenuse. Well, the hypotenuse, that area, okay, gives you the probability when the two events are added. It's not strictly addition. It's adding like I said, you always know the hypotenuse is going to be bigger, okay, but you don't, I don't know how to say that. Well, it's, it has to be the bigger side for that to work as an analogy. Yeah.
And finally, if an experiment is performed which is capable of determining which alternative is taken, the probability of the event is the sum of the probabilities for each alternative. That is, you're losing interference. Now, the question is, how does it really work? What machinery is actually producing this thing? Well, nobody knows any machinery. Nobody can give you a deeper explanation of this phenomenon than I have given. That is
all right, so of course they can. The first thing they can do is point out that the pattern isn't right. Okay, the real two-slit pattern is more complicated. And then they can point out that the math doesn't really work, and that the math that does work identifies 4 point sources. And the 4 point sources are exactly where the surfaces are. And that math works. So they can explain it.
Description of it. They can give you a wider explanation in the sense that they can do more examples to show how it's impossible to tell which...
No, they, again, yes, we could do more experiments to clean this out. So it's like the radar experiment. You could do another kind of experiment to try to duplicate the two-slit experiment, but then you could figure out in the radar experiment that, oh yeah, the geometry is exactly the same as jamming. So now we're stuck with how we receive a photon. How do we detect photons? And that's where the real problem lies, is that we can't detect pieces. We can only detect when they're put back together. And that our ability to do radio waves means that we don't have a light detector analogy to the radio. The radio has to tune into a band of frequency. It can't, and it's completely blind directionally unless you make a directional antenna. So in that circumstance, you can jam it. And the jamming math is exactly the same as this interference.
Which hole it goes through, and at the same time not destroy the interference pattern. They can give a wider class of experiments than just the two-slit interference experiment and so on, but it's just repeating the same thing to drive it in. It's not.
So it doesn't drive it in. The whole point is if you do these different experiments, you see these limitations and these things, and you demonstrate that there's a big difference between an electron and a photon, and a water wave. That there are huge differences in these things, and they can't be just says it seems like it is like. No, the fact is that it seems like, and that's just a coincidence. It isn't like.
Deeper, it's only wider. The mathematics can be made more precise. You can mention that they're complex numbers instead of real numbers and a couple of other minor points which have nothing to do with the main idea.
Yeah, I don't know where the complex numbers come in. Frankly, where do we need that? In the two-slit analysis? I don't think so.
And the deep mystery is what I described. And no one can go any deeper today.
So he said it, but yes, even in his day, there were people who actually knew the two-slit experiment doesn't look like that. It looks different than that squiggly line you drew isn't really accurate.
But only wider.
So again, they could go deeper to point out, well, the experiment you showed, like you really did it, you never did that, right? So you do, yeah.
Now, I mentioned probabilities in this calculation. What we're calculating here, this curve, is the probability of arrival of an electron. The question is there any way to determine where it really arrives? We are not averse to using the theory of probability, that is calculating odds, when a situation is very complicated. You throw up a die, and it spins so many times. And the air with a very...
Right, and we all know that that's not being controlled by God, right? So you don't really believe that God is flipping the dice, do you? No, you know that it's real physical mechanics that causing the effect. So why are we saying that the small universe has to do something different?
There's resistance and atoms and all this complicated business that we're perfectly willing to allow, that we don't know enough details.
There you go. Bingo!
And so we calculate the odds that the thing will come this way or that way. But here, what we're proposing, is it not, is that there be probability all the way back at the fundamental laws.
So there he said it, okay? So just understand what you're believing and why you're believing it. He's saying, okay, that the elemental universe is confused and variant, and I can't create the same circumstances and get the same results because there is no circumstance. There is no reality. It's all in some morphe religious blob thingy. Why are you believing that? On this thin, vaporous mush as evidence.
That in the fundamental laws of physics there are odds. For example, suppose that I have an experiment so set up that with the light out, I get this interference situation and know that. Then I say that with the light on, I can't predict through which hole it will go. I only know that each time I look, it'll be one hole or the other. But there is no way to predict ahead of time through which hole it goes. The future...
Like I said, so if we could aim photons, I would argue, okay, that this wouldn't be complicated. In the sense that we shot photons through both slits at the same time, you know. But we knew, okay, we deliberately put half of them through one slit, half of them through the other slit. You know, that's the complication. Because we have to have them have the right phase going into the slits to be able to reconstruct photons at the right phase. So that's the complication. But if you aim them and shot one single photon at a time through a slit, you'd find out that guess what? You don't get anything some of the time. You get a few photons that land right in the middle, okay? They won't even diverge much, or any. There'll be no divergence. They'll just all go straight through the slit. And all the ones that are fragmented, you'll find there won't be anything to put them back together with. There won't be another photon to break, to make pieces, to reconstruct photons. So if you do the single photon experiment correctly, that is, you send at a target with nothing in the way, and you get it weak enough to create one photon in one period of time, that is, one every 10th of a second or something, no more than that, and then put the slit in, I'll predict no pattern.
In other words, is unpredictable. It is impossible to predict in any way from any information ahead of time through which the thing falls.
So he just said it, right? He just said it, that somehow we have to believe the gun is all wacky and the truth is wacky and the wacky path and wacky everywhere and it's all just a bunch of woo.
The thing will go, or which hole it will be seen by.
And where the woo starts, right? What exactly about how the photon is created, where does the woo happen? Are the protons wooing? Are the electrons wooing? What part of it is wooing to create the magical random thing? Does the photon, as it's traveling through space, is it wooing then? Where's this woo introduced? He says it's fundamental, but he won't tell me where in the process it's fundamental. Or elemental.
That means that physics has kind of given up if the original purpose was, and everybody thought it was.
Yes, everybody thought it was. The original purpose was to discover the truth, which should be the statement, and to do so in some reliable, dependable, scientific way where you actually compile real evidence and you provide real fossils and you don't just tell stories. That would be nice. And you have real chromosome evidence and you have real geological evidence and you bring real rocks, into the display table to show us real rocks and real things coming from real places, and it isn't all a bunch of very superficial thought experiments.
To know enough that in given the situation, you can predict what's going to happen next. Given the circumstances, you can predict what happened. Given the circumstances, source, strong light source, tell me which hole, behind which hole will I see the electron?
There's no snow on the mountain. I'll predict that the snowball will not turn into a giant avalanche. There, I made a prediction. It's impossible, though. How could I possibly know that? Yeah, when God is rolling the dice. God says there's an avalanche. I don't need any fucking snow.
You say, well, the reason you can't tell through which hole you're going to see the electron is it's determined by some very complicated things back here. If I knew enough about that electron, it has internal wheels, internal gears, and so forth, that this is what determines through which hole it goes. So it's 50-50 probability.
So we know these little tiny things don't have any complicated gears because they do really simple things. You travel from point A to point B in a straight line, all that kind of stuff. And we know that electrons are only moving wacky because they're being forced to. Forces make electrons move funny. Charges and things. A proton makes electrons do something. Not nothing. Something does.
Because like a die, it's set sort of at random. And that if I were to have studied it carefully enough, your physics is incomplete. If you get a complete enough physics, then you'll be able to predict through which hole it goes.
And he's saying that's just wrong. And I've given you good reason to believe that no, that's not correct. There isn't a physical universe with, conservation and rules and that kind of stuff. Fuck that. It's a wooey-verse.
That's the hidden variable theory, so-called.
Right. The fact is that you're ignorant. That's the theory, right? It's not the hidden variable theory. It's you're a dumb, ignorant fuck theory. You don't really know, and yet you're saying you know. That's the point, right? So this is just dumbass. Arrogant dumbass theory. It's not hidden variable. It's you gave up on even trying to draw it and mechanically understand it.
Well, that's not possible. It is not due to a lack of detailed knowledge that we cannot make a prediction.
Right, he's saying it. He's asserting it as a fact, and it's no more factual, okay? It's no more proven than Jeebus walking on the water.
As I said, that if I didn't turn on the light, I should get this interference pattern. If I have a circumstance in which I get that interference pattern, then it is impossible to analyze it in terms of saying it goes through here or here. Because that curve is so simple, mathematically a different thing than the contribution.
Right, and we know it's mathematically a different thing because, yes, the contributions are really 4 sources. You're not just adding one source, 1 plus 1. You're adding 2 plus 2, which is very different.
Of this and this as probability. So if it were possible for you to have determined through which hole it was going to go if I had the light on, the fact that I had the light on hasn't got anything to do with it. Whatever gears there are back here that you observed, which permitted you to tell me whether it was going to go through 1 or 2, you could have observed if I had the light off. And therefore you could have told me with the light off which hole, each time an electron goes, which hole it's going to go through. But if you can do this, then that curve would have to be represented as a sum of those that go through there and those that go through there, and it ain't.
So again, we know that this isn't about going through a slit, right? The math that works has 4 point sources. The math that works demonstrates that this is not about going through an opening. It's about interfering with a surface.
And therefore, it's impossible to have any information ahead of time as to which hole it's going to go through when the light is out, or when the light is on, or out, in a circumstance where the experiment is set up there can produce this interference. So it is not a lack of unknown gears, a lack of internal complications that makes nature have probability in it. It seems to be in some sense intrinsic. Someone has said it this way: nature herself doesn't know which way.
And who would say that but a silly person? God has magic dice, okay, and he rolls them. Because even God doesn't know what magic dice are. He doesn't know how they work.
Where the electron is going to go. A philosopher once said,
so he's going to be pompous, he says. Pompous. Alright, so I would say this is where physics goes completely wrong, because it starts mocking a principle that seems pretty solid as a foundation for a physicist. A physicist should go about walking up his staircase. The first step he should be stepping on is probably this step, and they don't like it.
It is necessary for the very existence of science that the same conditions always produce the same result. Well,
yeah, right. So he's saying you can't even imagine the same conditions. You can't even in any way break this quantum woo thing down and say, well, what if I actually did create the same quantum woo? Then I'd have the same quantum woo out, right? But no, I can't even do that. I'm not even allowed to imagine, that the quantum woo has a structure.
They don't. If you set up the electrons in any way,
They almost applauded. They almost applauded that. So physics really isn't about physical. It's not about mechanical. It's about a redefinition of God as the randomness God. The randomness God will come to your rescue someday.
Set up the circumstance here in the same conditions every time, and you cannot predict behind which hole you'll see the electron. They don't, and yet the science goes on in spite of it, although the same conditions don't produce the same results. That makes us unhappy that we can't predict exactly what will happen. Incidentally, you can make a circumstance which is very dangerous.
Well, we already know this, that we can't predict. We already know their system's way too complicated or way too small. We can't predict any of this weather stuff perfectly because, yeah, we can't account for every atom. But do you really think the atoms aren't doing it? The movement of the atoms isn't creating the weather? Do you really think so?
Serious, and man must know and still can't predict. For instance, we could cook up, I know that not, but we could cook up a scheme by which we arrange photocells so that if it see the electron, one electron is going to go through. If we see it behind hole number 1, we set off the atomic bomb and start World War III. If we go see it behind hole 2, we have just to make peace feelers and delay the war a little longer. Then, the thing is that the future of man would then be dependent upon something which no amount of science can predict.
Well, of course, that is possible to create because we do have limited vision. I mean, we really just can't see everything. So, yes, we can't be certain of some things' position, but that's a limitation of our perception. It's not a limitation in the reality. Again, this is just such bad logic, and it's such terrible, weak evidence to defend the bad logic.
The future is unpredictable. What is necessary for the very existence of science and so forth, and what the characteristics of nature are not to be determined by pompous preconditions.
Pompous precondition. It's not a precondition. It's just knowledge that, it seems very likely, okay, that everything in our big universe is accountable. And so why would we think that the place where we're going to make our gremlins, right? We can't make them in this big physical world. And the place that we are saying the gremlins exist just coincidentally happens to be the place we can't see. It's just a coincidence that, the place where the gremlins are, it just happens to be the place we can't see. I mean, that doesn't smell of overt coincidence.
To be determined, they are determined always by the material with which we work. By
convenient coincidence.
Nature herself. We look and we see what we're going to find, what we find, and we cannot say ahead of time successfully what it's going to look like.
Yes, of course, we can't say. That's fine. Yes, we can't say because our vision is limited, not because nature is full of gremlins.
Reasonable possibilities turn out often not to be the situation. What is necessary for the very existence of science is just the ability to experiment.
So, the ability to experiment, he says it, and yet this isn't based on experiment. This isn't based on the actual, the two-slit pattern actually looks like. This isn't based on anything to do with actual evidence. This has to do with creation science. These aren't real fossils. These were manufactured in the little, Christian hovel somewhere. This isn't real evidence.
Honesty in reporting results.
Honesty. Where's the honesty? Where's the honesty in reporting Eddington's, results were 1/10 of what he had hoped for? Where's the honesty? Where's that report stated? Oh no, it's proof. It's proof. New York Times headline: Einstein proven right. Where is your honesty? All the other experiments have to do with scatter. We figured out it wasn't scatter with our magical. It wasn't scatter detector. I mean, the whole thing is just covered in dishonesty, in fudging, in making it up, in aggrandizing it, in exaggerations. Oh, these preposterous exaggerations. We have the most reliable formula in the history of mankind. It's predicted everything. It predicted Donald Trump would be president someday.
Results must be reported without somebody saying what they like the results to have been. And finally...
Exactly. You just did an experiment where you just made it up, and so it fits your model. And that's it. You made up the evidence. You presented your made-up evidence. You fooled the crowd. All right. But, somebody like me who figured out an electron is 1 trillion times smaller than a photon figured out the obvious. You never did this fucking experiment.
The important thing is the intelligence to interpret the results, but important point about this intelligence is
that you can use it to scheme and to manipulate and to fool people. You can use intelligence to fool suckers. And as Barnum says, there's one born every day, and you could fool some of the people some of the time, and fool all of the people some of the all the people some of the time, and some of the people all the time. And clearly, physicists can be fooled really, really easily, because they're little nerds who make things into icons, and they just want to follow their little icon. I love Feynman. Yeah.
And it should not be sure ahead of time about what must be. Now, it can be prejudiced.
Yes, you can be prejudiced, and that's exactly what you are. You clearly have a bias. You've distorted all of the evidence to fit your model. You haven't fairly explained a damn thing, because if you fairly explained it, then the audience would say, what the fuck are you talking about?
And say, that's very unlikely. I don't like that. Prejudice is different than absolute certainty. I don't mean absolute prejudice. But
and where's you've made absolute statements. It can't possibly be. You can't possibly. It's just so overt duplicity. Don't be overconfident. Don't jump the evidence. Accept as much as we already have. Only jump the evidence where we jump the evidence. Do as I say, not as I do. Yeah, that would be totally fitting here.
Bias. But not strict bias, not complete prejudice. As long as you're biased, it doesn't make any difference, because if the fact is true, there will be a perpetual accumulation of experiments to perpetually annoy you.
Right, exactly. But in the modern era, that doesn't happen, because you control all the experiments. You control all of the stuff that gets published and gets recognized or gets seen or get viewed. And people like me have to sit way far away, okay, with no megaphone, and go, peep, 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 you're full of shit, Feynman, you're full of shit, Feynman. But no one will ever hear us, because you've kept us so far away.
Until they cannot be disregarded any longer. Only can be disregarded if...
Yes, finally you will crumble and fail. Finally people will figure out bent space is horse shit, doesn't make any sense at all. And they'll figure out that mechanics makes sense, and quantum makes sense, but this crap you're teaching doesn't make any goddamn sense.
We're absolutely sure ahead of time of some precondition that science has to have. In fact, it is necessary for the very existence of science.
So what's the point, right? We have these laws of conservation and different things that seem really reliable, really dependable, the inverse square law, different things. So these are solid. There's no reason to think we can't define anything. Of course we can. And we can assert it with confidence. But this isn't the inverse square law. This isn't conservation of energy. The theory he's arguing for is something much wooier, and he has much less evidence.
That minds exist which do not allow that nature must satisfy some preconceived conditions like those of our philosophy.
All right, so he calls it philosophy. Okay, so conservation of energy is a philosophy. So it's not a rational deduction after millions of experiments. Okay, and what I'm arguing is that we've done millions of experiments on things that we can see, and the things we can't see, we have to make some correlations, and we say we can see some kinds of evidence of stuff. Sometimes they do something we don't fully understand. So what did they do? They jumped to the conclusion that we don't understand it because it's wooey and it's gremlin-y. Not that we don't understand it because we don't understand it. We're missing one of the variables. We're missing the fact that the photon is a composite object, and that the composite object is being rearranged by the obstacle course you're putting it through, and you're rearranging it on the target, and you get some of your fucking photons back. Simple answer, not even considered. Certainly not counter-argued. Certainly not debunked by any of these physicists. So as a side note, I mean, I did ask Piro, for a Skype conversation, but he hasn't made a video, so maybe something happened. He drowned in Lake Webegon or whatever. So nothing there. The physicist I had contacted still hasn't contacted me back, and I've already asked him once before about, you're taking a long time, can't you? And he made excuses, and so I was just figuring, well, he should contact me. I shouldn't have to keep badgering him. So who knows? The simple answer is I think he's failing. So now I did push Baldy Katz again on his debate channel, and point out that he had a debate with a Christian flat earther kook or something like that, who was kind of rude to him in comments. And so apparently being rude in comments shouldn't be some disabling consequence. He should still be willing to do it. Now, I didn't charge the flat earther to debate. I'm willing to pay him, and he still won't, man up. So they're just such fakes and phonies, these people. Full of, yeah, give me a stage and let me control, and they're fine. But right, under real interrogation, all of this shit falls apart. So, till the next time, when I will continue to plead with you to be reasonable people. Don't trust them. Again, they can't explain the simplest experiments accurately. They can't show it to you accurately. They can't describe it accurately. Again, look at that Fermilab guy saying the Eddington experiment was about seeing a sun behind our sun. Seeing a star behind the sun. He can't even get the experiment right. He can't even describe it right. And you trust him to tell you what his little accelerators are doing and what wacky particles they found. Why do you trust them? They're showing you how unreliable they are.